Hello everyone, hope you all are doing good. My name is Isha Singh and I'm working in Claranet as an engineering manager. I'm leading the dev team of Claranet and I'm responsible for all the development related work here. Today I'm here to talk about one of the very popular topic, that is Redis. So every software engineer might have heard this word one or the other way. Also guys, please reach out to me if you have any suggestions or clarifications required out of this session. So let's move to the next slide. So this is the agenda of our today's session. So these are the listed topics which will be covered as part of this session. So we are going to talk about Redis, basically what is not Redis, a difference between Redis and RDBMS. Also, we are going to look into very popular 5 use cases of Redis. Then we are going to talk about advantages of Redis, like when to consider Redis, what is the importance. Then we are going to look into architecture, data types, commands, topologies like Sentinel, standalone, etc. Also at the end, I'm going to present you guys a small demo using a Redis CLI and show you guys how the commands basically works using CLI and also integrating our application through Golang. So what is Redis? So Redis stands for Remote Dictionary Server. It is an in-memory database. So many people have used it as a cache on top of other databases to improve the application, basically the performance. So however, what many people don't know is that Redis can be used as a primary database which can be used to store and persist multiple data formats for complex applications. On top of that, Redis can be a good fit for caching and message broker. So now we are going to look Redis into more depth. So as a developers, we often have to make decisions about like what to use in the front end, back end, and the middle tier, which must include some choices around database. When we made any decisions on how to solution Redis in our architecture, we use the three simple categories to categorize their importance. And what were they? So they were flexibility, how flexible Redis is, the implementation, how easy it is basically to implement Redis, and of course the deployment, the most important thing. As I mentioned before, Redis is an in-memory data store. That say that everything you put in sits in memory, so it has to be very quick and easy access to it. But the role that it plays great is as basically a cache. So it can also function as a fully fledged data store if you would like to. And of course, if you want to even dig deeper, there are certainly some messaging capabilities, as I told in my previous slide. Now, when we talk about cache, what exactly do you mean? Well, that can be any type of structures from string to hashes to list. I think we all just got a picture about what can fit definitely into a database there. And in your architecture, so basically, when I think you as a developer or a mobile developer or a web developer, in practice, I know there are some times when I just want to just put a set of data somewhere quickly to access it later, and this is really where this shines. So it has really helped me to know categorize it when I needed a quick place to cache something very easy. Redis was a strong check. So let's actually put a check mark there now. So the implementation, there are certainly all types of SDKs which are available from C to JavaScript to Java to Python. Just be sure to check it redis.io for all the SDKs that are available in the market. But that was a very important factor for me. So depending on the language of choice that I want to develop, with how easy it is to actually integrate and implement the infrastructure, there the data structure what I want to save. Also, one thing that was a very big bonus is that Redis can also be compatible with a lot of IoT applications. As per my experience, it is very easy to bring up the first Redis instance. Until now, this is what just an entry conversation of Redis as your database choice. Feel free to check out the redis.io for more information. Let's move to the next slide. So, what is not Redis? So, Redis is far faster than RDBMS, but it also can't do as much. If you can map your RDBMS use case to Redis, then it might be worth taking a look. But if you can't, just don't force it. So let's see what is basically the differences between Redis and RDBMS. So Redis is a free and open source cache database, whereas RDBMS is simply a program that manages database. If I take storage as a parameter of comparison, in Redis everything is stored in primary memory, whereas in RDBMS everything is stored in secondary memory. Let's talk about speed. So since Redis store data in primary memory, read and write operations are extremely fast. Because RDBMS store data in secondary memory, read and write operations are really slow. Let's look into the cost. Primary memory is significantly more expensive. So thus storing data using Redis is costly too. Secondary memory is relatively cheaper, thus storing data is cheap too. If I talk about storage capacity, due to the small primary memory, Redis cannot store large files of binary data. The secondary memory is abundantly large, so RDBMS can handle such files easily. If I talk about type of data stored, so Redis is usually basically used for storing very small textual data that needs to be accessed, modified, and inserted quickly. You will receive an error if you try to write bulk data beyond the memory available. And RDBMS can hold large amount of data that are less frequently utilized and are not expected to operate at high speeds. So now we are going to talk about Redis use cases. So there are 5 use cases: caching, queuing, locking, throttling, and pub/sub. So there are many popular sites which are using Redis. There is Twitter, Instagram, Vine, GitHub, Stack Overflow, Pinterest, and many more. So in my next slide, we are going to look at each of these in detail. So let's talk about all the 5 use cases in detail. So let's dig deep in what this diagram is all about basically. So on my left side, there is a web server, and on my right side, there is a query worker. So query worker is basically a background worker. And in the middle, we can see all the use cases which I listed in my previous slide. So the first use case is caching. Let's assume there is a very popular celebrity on Instagram, on Facebook, which a lot of users may intend to visit. Here we can easily avoid multiple database query by caching that profile near to application. This is fairly simple to achieve. On the first profile request from the web server, we will make a database call to retrieve the profile information and then cache this to Redis. During the second call of the same profile request, we will check if the profile exists in Redis. We just return the profile immediately without just going to DB. So what we are gaining here is twofold. So one thing is obviously the speed. We can react faster to the profile request. Second thing is that we are offloading a lot of resource consumptions from the database. So the second step or the second use case is queuing. If we have some non-transactional use cases, there we can wrap the data into a message and put it into the queue. And then it gets consumed on the other side by the worker. And so obviously what we gain here again is twofold. First of all, we gain decentralization so that the web server maintains its concerns of serving the API's request, while we can sort of separate the query itself into a background worker. And then the second one, the goal that which we are achieving is sort of independent auto scaling from of each side of this diagram. So if I have thousands of web requests incoming and my instance of the web server can handle the load, but the backend query worker just need to adjust the workers. Now let's consider a different problem statement where the web server requires some sort of impressions. So the third step, or I can say locking, the third use case. So once the query worker has consumed a message and it's about to perform the query with the data warehouse that's on my right hand side over there, it's a small image. The first thing we do is that we can acquire a lock in Redis, and there are two reasons that we do that. First is resilience, because we don't want to thrash the data warehouse with tons of concurrent queries. And the second thing is, which is a difficult part, is a multi-tenant platform, which means that all the customers that have their data stored on the same infrastructure and on the same storage, and so we want to avoid the situation where we have a noisy neighbor, or in other words, a customer that is sending tons of requests concurrently and then sort of hogging all the resources of all the query workers and starving all the other customers. So the logs are as per the customer basis. And if I extend that a bit, it's not exactly a log, it's actually a semaphore. So for example, if I'm a customer and my account can have say 10 a request and a semaphore of size 10, so I have 10 permits I can acquire. So which means I can concurrently perform 10 queries on the data warehouse. And just one more word about the data warehouse, the tiny icon on the right hand side that you will see. Well, look, it looks very small, but in practice, it's a monster. So this behind the scenes, this is a huge warehouse. It has 30 different shards and each shard is deployed across 6 nodes. These are really big machines on Amazon petabyte scale data. So it's a big operation, and eventually what we achieve as a company is that we can query the data in sub-second time. So the fourth step, or I'll say the fourth use case, is that once again, since we are building a fail-safe system, if acquiring the lock and step number 3 failed, then what we do? We throttle the message and the message stream that's incoming, or in other words, we re-offer the message back to queue with a certain delay that is assigned to it. And we are using a Fibonacci strategy delay. That particularly means that every time a message comes back from the key 1, we need to re-offer it some sort of a delay. It more than that, we can increasing the delay a bit until we reach a sort of maximum retry, a max threshold of reach. Why that's there, or we just don't want to perform the query, but that sort of gives us another level of resilience. And the main thing actually that we are gaining here is congestion management. So if once again, if we have to burst of queries that are incoming, then we can just sort of manage and balance the load and ease it over time eventually. And we can perform all the queries even if it takes it a bit more than a few seconds, like that. So step number 5, or the final step, or I can say the final use case, is once we have acquired the lock, we have performed the data warehouse query, and now we want to return the response back to the customer. So first of all, we are going to put the response back in the cache. And what we are doing is we are publishing and subscribing. So where we are actually publishing them, the result back on a pub subtopic back to the web server. Now the reason we are using a pub sub here is all the queue in that we need full coordination between the web server instance that sent us the query, and that same instance needs to get the response back. And the reason for that is that the customer is connected probably via a WebSocket. And so WebSockets are stateful connections. Once the browser opens a stateful connections with one of the web server instance and triggers a query, then we need to return exactly the same web instance and back to the client. So both the web server and the query worker at this step are sort of coordinating between each other on a pub sub topic, which is the unique identifier, which I mentioned in my step 2 when we were queuing the message with some kind of unique ID. So that's what we are gaining here. We're gaining immediate feedback to client. So this is pretty much which covers the flow in the system. So let's move to the next slide. So in this slide, we are going to talk about when to consider Redis. So Redis is primarily an in-memory database, which I'm talking since the beginning of this conversation. So there's no guarantee that data has actually been written to disk when a Redis command returns. So server crash is very likely to lose some data, eventually consistency. So there are a number of ways in which we can just improve durability, generally by trading off performance. So let's move to the next slide. So this is, let's talk about Redis architecture. So this is just a general architecture. So I'll just talk about some few points related to the Redis architecture. So Linux is the recommended here. In Windows, if I talk about, there is no official support for Windows, but Microsoft develops and maintains an open source, which is Win64 port for Redis. So you have to install that port, and then you have to do some connection, and then it's going to be working on Windows. Apart from that, it executes commands using complexity with a minimum lines of code. All operations are atomic. No two commands can run at the same time. And it's written in C. And it works in most systems like Linux, BSD, and OS. So this slide just shows the general architecture, which covers all the commands, the topologies, which we are going to cover in some time, Sentinel, cluster. It also tells about what are the commands or what are the data types, string, hash, sets, layers, data structure, and sorted set, etc. So we are going to talk about these in details. So let's talk about Redis data type. So binary safe string means that values are essentially byte string and can contain any byte, including the null byte. A hash allow compound objects to be stored in a single Redis value. A list work fine as a queue or a stack with blocking capabilities. Sorted set works like a set, but each member has an associated score. The set is kept ordered by that score, and range of queries are extremely efficient, stored in either direction. Then we talk about hyperlog. Hyperlog provides a good approximation of the cardinality of a set using very small amount of memory. In Redis, it only uses 12 kilobytes per key to count with a standard error of 0.81%, and there is virtually no limit to the number of items you can count. So this is like an example, the key values shown here. So we are going to take, I'm just going to show all this in Redis CLI soon. So Redis command basic, let's talk about Redis command. Strings, keys. So if anyone wants to have a full list of commands, there is a page, redis.io/commands. If you click on that page, you will see all the Redis command listed. So if I talk about more commands in detail, like list and hashes. So what lists do? Lists are doubly linked lists. You can push and pop at both sides, exact range, resize, etc. Random access and ranges can be considered. Hashes, hash tables as values. Think of an object store with atomic access to object member. Let's talk about sets, sorted sets. Okay. So sets are sets of unique values with push and pop, etc. Sets can be intersected, diffused, union, server side. If I talk about sorted sets, same as sets but with score per element, ranked ranges, aggregation of score, or intercept. Now let's talk about how we can scale Redis. So persistent. So if I talk about persistent, the RDB persistent performs point in time snapshots of your dataset at basically specified intervals. The AOF persistent logs every write operation received by the server that will be played again at server set startup, reconstructing the original dataset. It is possible to combine both AOF and RDB in the same instance. In this case, when Redis restarts the AOF file, will be used to reconstruct the original dataset. If I talk about replication, slave writes mode can be enabled but will be ephemeral until restart or resync. Slaves provides data redundancy, reads offloading, and save to disk offloading. We'll talk about failover mode in detail in topologies. So now we are going to talk about Redis topologies. So they are standalone, sentinel, that is automatic failover. We have term proxy, distributed data, and a combination of second and third, that is cluster, automatic failover, and distributed data. So we are going to see each of these in detail in our next slide. Let's talk about standalone. So you are seeing a diagram in my presentation. So the master data is optionally replicated to slave, which is very clearly shown. The slaves provide data redundancy and it reads offloading and save to disk offloading basically. So client can connect to the master for read and write operation or to the slave for read operations. Slaves can also replicate to its own slave. There is no automatic failover here. So in standalone, the point to remember is there is no automatic failover. Now if I talk about Sentinel, so Redis Sentinel provides high availability for Redis. In practical terms, this means that using Sentinel, you can create a Redis deployment that resists without human interventions to certain kind of failures. Sentinel process cooperates for failure detection. Multiple Sentinels that agrees about the fact like a given master is no longer available. Sentinel works even if not all Sentinel processes are working, making the system robust against failure. So one thing to remember in Sentinel, it is basically an automatic failover system. Let's talk about TWEM proxy. So TWEM proxy works as a proxy between the clients and many Redis instances. So it's able to automatically distribute the data among different standalone Redis instances. Support consistent hashing with different strategies and hashing functions. Multi-key commands and transactions basically are not supported here. So this could be a combination of the first two. So automatic distribution of data and proxy for Redis. Let's talk about cluster. So cluster is a combination of second and third. So Redis cluster distributes data across different Redis instances, and it performs a automatic failover. If any problem happens to any master instance, all nodes are directly connected with a service channel. The key space basically is divided into hash slots, which you can see in the diagram. Different nodes will hold a subset of hash slots, and multi-key commands are only allowed for key in the same hash slot. So what are the Redis advantages? So Redis advantages are it's a very high performance, designed for speed in memory operations. It is very highly available. Sentinel cluster application partitioning, fault tolerance, failover mechanism, as I already told in that topologies, manual and automatic both is supported. Scalability scales down as well as up, so it's equally useful for tiny projects as it is for the huge services. Portability runs on multiple OS and multiple client languages. Okay guys, so let's proceed for the demo. First we will see the basic CLI commands, and then we are going to integrate with one of our Golang application. So let's move to the next slide. So I have pre-installed Redis in my system so that we can quickly get started. So we'll type Redis CLI to bring up the CLI for Redis. And I'm also going to clear all the keys which I have locally by using a simple command flush all. So first example we will see is setting a key value of type string by command set key value. So set key 1 value 1. Okay, so now we have set the value. Now let's try to get the value by using get key. Now in the response you can see the value is written here, which means it was stored in the Redis. Now we'll try again. So now we will see the similar example, but we are going to set this time the expiry of 5 seconds. Set key 1 value 1. Expiry of 5 seconds. We are getting key 1. Again try get key 1. Get key 1. It's nil. So it got expired automatically after 5 seconds. Now we will see multiple set. So key 1 is having value 1. Key 2 is having value 2. Okay. Now let's check the keys. How many keys we have? So we have key 2 and key 1. Now let's try to get key 2. So it is assigned with value 2. And if we try to get multiple keys at a time, key 1, key 2 will get value 1 and value 2. So now let's see the similar example integrated with Golang application. So we are using Go Redis library. This is the Go Redis library. We have created Redis client as a variable of type client Redis. Now in the main application, we will first initialize the Redis client. and we are going to use the local Redis address to connect with, that is localhost. Same way, we are setting up value without expiry, keep value without expiry, and we are printing it. We are also setting value with expiry, and expiry time we are giving here of like key1 value 1, and we are giving time as 2 seconds of expiry. Then we are getting the result, printing the value, basically printing the result. Then we are doing mset for key1 and key2. So key1 has value 1 and key2 has value 2. We have a sleep time again here for 2 seconds. Now here I am getting the result, I am get key1, key2 and the result, printing the result. So let's now run our application. Go run main.go. So this will run our main application. So now see here, demo set value without expiry. This is the one, key1 and value 1. Correct, you are getting value 1. Demo set with expiry of 2 seconds. So it is basically getting expired. So we are getting null here. Now demo mset value for key1 and key2, and values by mget value 1 and value 2. So that's it. This was a small demo using the Golang application. So on that note, during the session, there were certain topics which I have just touched upon at a very high level. So that was just a tip of iceberg. If you need any more details, you can just visit to the references mentioned in each slide. So that's all. Thank you, everyone. Bye-bye.